All right, today is called difference quotients. Okay, the difference quotient is one of the two topics that we have for today, and the other is taking two functions and adding them, subtracting them, multiplying them, and dividing them. All right, so here is two functions. Those two functions can be added. And how could you write, I want to add them? You could write f of x plus g of x. That is the most straightforward way to say add these functions. But can you give me two other ways to say the same thing? Two other ways to say the same thing. Yes, sir, give me one of them. That's actually the answer, but what I'm asking is how could you write the question? You're right, that's the answer. How could you ask the question a different way? Because they're not gonna say it this way when they say add them. All right, this is one way. You get that means f plus g of x? All right, and that's really the only other way that you'll ever see. I can make up another way to say just f plus g, but we're always going to say of x. All right, so how do you actually add them? Oh my gosh. You just add them together. You just say this plus this. So it's x squared plus x plus 2. That's it. Done. Adding them is super simple. Now subtracting them is a little more complicated because if you do f minus g, that's what they would be saying, f minus g of x. Then you got x squared. Here's the common mistake. X squared minus x plus 2. Well, what's wrong? I put this one function, I put the other function, and I subtracted them. Yes? Yes. And that will change it, really, doesn't it? Because now that 2 isn't a positive 2 anymore. Okay, so that's the common mistake is people forget parentheses. That's a big deal. It still continues to be a big deal. From last chapter is a big deal. It's still a big deal. So be careful with those. If you're subtracting f of x from something, you need to think of that as a y, so it's got its own parentheses around it. So if you know what f of x is, you drop it in there into the parentheses. So just use parentheses. All right, multiplying the functions. Why don't you tell me what you think f times g is? Again, I could see some kids not distributing because they don't use a parentheses. To multiply them, you should have said x squared. Notice the parentheses, x plus 2. So x to the third plus 2x squared. Raise your hand if you had that one right. Okay, good. That's multiplying them. And last is dividing them. What is f divided by g? We usually write it like that. Not with a divide by sign, but with a fraction. All right. That divided by that. It's that simple. Now, if you can factor it, you should. The top can be factored, and the bottom can't be. So can you cancel? Can or can't you cancel? No, you can't. Can't do that because this one's being added. They have to both be multiply problems for that to work. All right. So this one, bottom line then, can't be simplified, so that's the answer. That's adding them, subtracting them, multiplying and dividing them, and that's the things that you're doing for today. Now, of course, the functions get more complicated than this, but that's kind of the overview of just adding functions, subtracting them, multiplying and dividing. Tomorrow we get into the domains of them, and that's where it gets more complicated. All right, then here's the other thing. In the old days, let me actually back up a notch here and say, in the old days, you guys did slope, and it was really simple because it was a straight line. And then if you picked a spot here and you picked a spot here, and this was like over 8, and this was up like 5, what would the slope of this thing been? Rise over run, and so therefore 5/8. Do you get that the slope is the same the whole way through? Okay. It's how steep it is, how steep that line is. But what happens if now your functions, as you move up to pre-calc and calculus, they're more like that? Do you get that the slope isn't just always the same? How in the heck do you do a slope if it's all curvy? You pick a point on it and then say, at that spot right there, what's the slope? And they'll walk you through all of this next year. I'm just trying to give you an overview here, but you make a line that just barely touches it. Okay? That line there, that one, you find the slope for that one. At this point right here, you would find the line that barely touches it. Now, on a circle, it would be called a tangent line, but we call it a secant line. You see how it's barely touching? It's like the only spot where you could draw a line, so it only touches at one spot. Anyway, so do you get this as a slope of one thing when it's here? It has a different slope here. And what if I pick this spot right here? That'd be a totally different slope. That'd be this slope. So the slope is all over the place. All right, so what you're doing today, when you do this, do you remember this one? We did that a couple times last chapter. When you do this and then you divide by h, that's the formula for slope. That's the much more complicated formula for slope. It can do slopes of simple lines like you learned in the first place, but it was way easier in middle school to teach you rise over run than to teach you that. But this can also handle finding slopes of curvy lines, not just straight lines. Okay? So let's use this beast to figure out the slope. It's the much more complicated but much more powerful formula for slope. And it'll even work on what's the slope of this. Now, I can tell you right off the bat what the slope of that is. Can you? Actually, let's change this to a different number so people don't get confused by that. What's the slope of that? Slope is 3. Because that's where the slope's supposed to go, and it's solved for y and everything. So I'm just going to show you that this crazy function here, this difference quotient it's called, difference because it's got that, quotient because of this divide line here, that means divide, quotient means divide, right? It's called the difference quotient. That difference quotient will also find you the slope. So how are we supposed to do that? Well, remember, y is the same as f of x, so this is a function. So this function is 3x plus 5, and we're going to stick that into it. Then we're going to subtract f of x. Then we're going to divide the whole thing by h. And the answer should come out to 3 if you did it right. All right, so let's just take it one step at a time. I'm going to stick x plus h into this function. I want you to do the same thing, please. Do this with me. Don't just watch me. When you're watching me, it'll all make sense, and then you'll remember 10% of it. You got to do it. So 3 parentheses plus 5. Notice those parentheses. Izzy, what am I dropping in the parentheses? Yep. And then I'm supposed to subtract f of x. What do I need right now before I forget? Parentheses. And in that parentheses, Mr. A, what do I drop in? Yep. The original function. See, I'm doing this part. And that's all over what? H. Just H. All right, now simplify the top part down. There'll be a whole lot of simplifying that'll happen. And you'll see that the answer comes out to 3. (3x plus 3h plus 5 minus 3x minus 5). Notice I'd be distributing the negative. If you thought it was a plus 5 at the end, you're wrong. All over h. And then the minus 3x and the plus 3x, they're going to cancel. The plus 3h, that stays. The plus 5 and the minus 5, they cancel. Look at that, 3h over h. Can you cancel in a situation like that? Yeah, you got to think of this as a 1 times h if you want to like realize that it's actually a times problem. Okay, and then the h's can cancel and you get 3. Just like we thought. So what good is this really complicated formula if you could have just looked here and said the answer was 3? Because it can also find you the slope of your classic parabola. You find the slope of that. Well, it depends on what point you want to pick. If I'm right here, do you get my slope will be, well, rise over run, and there it's not really rising at all. What is a line that goes like this? What is its slope? 0. Okay. How about, is it running? Yeah, it can run as far as you want, but the rise is 0, so it's 0 over anything, and that's 0. So at that particular spot, the slope is 0. Can you imagine there's probably a slope on here where it's a slope of like 1? And there's probably another spot like I picked there, and if I could make that perfect line that would touch there but no place else, it might have a slope of like 5. So it depends. How are you going to get an answer for that? Well, let's see what comes out. Take x squared. That's your function. And put it in the difference quotient. Just because some of you guys are so good at memorizing, I bet some of you already knows the difference quotient, but without having to look it up. How does it start? Keep going. Yep, that's the difference quotient. So now use that. Stick. This is your function. That's f of x. I'll pause while you do that. All right, I'm ready. Fire when ready. Okay, I'm putting it in there. So I'm putting parenthesis squared, and then I'm dropping an x plus h. Good. And then what? Yes, I could put a parentheses around this, but in this case, if there's only one term in your parentheses, then you really didn't need the parentheses. Okay. And then all over. Excellent. Common mistake answer is to say this is just x squared and h squared. But you didn't do that? Good. What did you say it was? Excellent. Then minus x squared all over h. And then what? Okay, just to clarify, let's just be careful on this. You can't just go like this and this. This is what, and I'm not saying you would have done that, but this is one of those moments that my favorite saying comes in. Can factor it, you should. So I can factor the top part. Factor out an h. Because you don't want to just go, oh, I'm going to cancel that one. Because this is part of an add problem. Can't do that. It needs to get factored first. So I factor the h out. And what do you have if you take an h out of both parts of this? 2x plus h. Good. And then this h cancels. There's your final answer. But that's supposed to be a slope. How's that supposed to be a slope? Well, it's saying is the slope depends. The slope depends on a couple things. What does it depend on? X and H. And I'm not trying to actually teach you the whole unit for calculus here, but that we just actually kind of touched around the edges of the whole thing. My job is just to get you to be able to do this formula right here and see how it simplifies down. And this one simplifies down to this. I'll leave the interpretation of all that to next year's teachers. I have plenty to teach you this hour. Okay, so if this is, we already did this one. This is the one where we had a function with this, and then what was its slope? 3. I can just look at it and see the slope is 3. But it was your first chance to learn to use the difference quotient. It's to find the average and instantaneous rates, which is like slope, at any point on a function. All right. This next thing is difference quotient practice. This is where you would to use the difference quotient, which we've written out several times here, f of x plus h minus f of x all over h, on all three of these. But I think you're going to be fine, except for on maybe this one. But I'd rather have more time at the end for you to get homework done, so I'm not going to do another practice here. I might do another one on your homework. Okay, so we'll keep going because there's more to learn. All right, here we have cost and price of cell phones. Let's use the ubiquitous iPhone. Apple doesn't actually make phones. News for you. They contract that part out. So when we say Apple made a new phone, they really didn't. They designed a new phone, and they're going to sell you the phone, but somebody else made it. There's actually a company called Foxconn is one of them, and there's another big supplier that makes all the phones. Okay, so Apple actually has to pay somebody else to make it for them. So Foxconn, for instance, sells they figured out the price of making this phone. The cost of the components is about $230 for an iPhone that they sell for $650. Like the little pieces that go into it all add up to $230. But then Foxconn also charges to actually put it all together, not just the cost of the parts, right? So they got the cost of the parts, then you got the cost of actually making it and finishing it, and then you got the cost of shipping them from China over here to the United States, and they got a bunch of costs. So when they sell it for $650, and you look up, again, this is a fresh article from just a few days ago, that the iPhone 7, the brand new one, had a cost of $230, I think it was. They didn't really pay $230, you had to pay all this other stuff. But let's say that when it's all said and done, they paid $400 for the phone, and they sold it to you for $650. Then how much profit did they make? $250. It was $400 compared to $650. That's $250 profit. Okay, Apple is one of the most profitable companies in the world. They can have, basically, that means they're selling their stuff for more than they would have to. Like a lot of other companies would sell the iPhone, instead of for $650, they'd charge $550. So everybody makes a markup, otherwise they wouldn't be in business. They want to make money. But Apple can charge even more than a lot of companies do. Just basically because you could argue their engineering is so good, everybody wants their stuff, so they can charge whatever the market will bear. You can bet if people would still buy the same number of phones, they'd charge $750 for the phones, or $850. All right, so do you get that then profit is going to be your price minus your costs? That makes sense? All right. So then do you see how that's a function minus another function? That's supposed to be a C. It's just that's an example of where you would subtract two functions. One place where I disagree with this is on price. That is a silly price function. That's where every extra unit they sell, they drop their price by 1. If Apple did that, their price would be negative like $1 billion, because this is a weird way to make a profit function. But they just wanted to include an X in their profit function, so I know some teacher just made this up. But I'm just saying, in the real world, you don't pick your price and then make it go down another buck every time you sell another one. That wouldn't make much sense. Now, I will say you can sell things cheaper when you sell them in scale, but again, you wouldn't want to make a function so that, because as soon as you make 150 phones, your price is how much? 0. Not smart. Okay. So I think price is much more a function of just the guys in charge sitting around saying, so what do you think? Should we charge a little more for the iPhone this year? Because it cost us more to build. And then what's going to be the argument back? Well, we don't want to raise the price, because then what? If we make it too expensive, people won't buy it. Or people will be complaining about Apple. They're already really profitable and they're charging us even more. And then Apple would be like, but we're having to pay more for our phone this year. So anyway, there's arguments that go on within the company, and then they just pick a price. They went with $650 as their starting price. And then they can, actually, Apple's been known to start with a price, and then when they react to how the market does, and if they're not selling enough, like when they had a product that wasn't selling very well, they just dropped the price $50 pretty quick. And then people were like, woo, it's way cheaper than it was a minute ago. I'll buy one now. And so they can adjust that price totally based on what their managers decide. Okay, enough on that. That's just showing you can actually take two functions and subtract them in the real world. All right, moving on to this one. Everybody get to this page. And this is where we would just add two functions, subtract the two functions, and I trust you on those two, but I think the multiply one might get you. I would like you to try to multiply these two functions. We've got a triple times a double. It is one of the things in the top 20 where you got to be able to do a triple times a double. See if you can do it. Take this, times it by that, and show me the answer right there. I'll pause while you give that one a try. Okay, so to multiply these two out, it's this times that. I'll actually write them out. Negative x squared plus x plus 6 all times by x squared minus 9. Okay. I have two methods for doing this. One I call the giant clam. This has to get multiplied by everything. And this has to get multiplied by everything. That's a total of 6 answers. And do you get how the outside kind of looks like a giant clam? Okay, like here's the crack in the clam if it wanted to open up. On the ocean floor, they're laying there, and actually a lot of people have died from the giant clam because they're really tempted to touch it, so they reach down, they touch it, it snaps shut on their hand, and now you're stuck on the bottom of the ocean because they're cemented into the ocean floor. And then you're like, okay, this sucks, wait a minute. And then if you're scuba diving, you've at least got a tank full of oxygen. And then you got to hope that you got friends who can come over and help get you out of this thing, try to cut the clam open or try to pry the clam off the ocean floor. If you're snorkeling, you have about 4 minutes. Because if you swam down to get there and you're trying to get up to get air, you're not going to be able to get back up again. So. Usually, have you ever heard of the dive knife? The scuba divers always have a knife. That's what they have it for moments like that. If they're stuck on something, they got to be able to get back up. Yes? Yes, you may. You don't have to ask about that. Just come on up. All right. So anyway, this is dumb, but it's just a way to remember that that's a way to get your answer. I'm going to show you a different one. Some people like to do it this way. Ignore these two and just distribute the 6 to both of them. You get how it looks like a distribute problem? That times that, that times that. And then go to the next one and say, all right, I'm going to try to take this now and distribute that one to both of them. And lastly, you take this one and distribute it to both of them. I think you get the idea. When you're all said and done, I'm going to see if I can get this. I have negative x to the 4th. Then I'd have somewhere in there a positive 9x squared. And I'd have a positive x to the 3rd. And I'd have a negative 9x. And I'd have a positive 6x squared. I'm putting them right next to each other so I can add them. And then I would have a negative 54 somewhere. All right. So only these two, I think, get added, and everything else is going to be the same. So negative x to the 4th plus 15x squared plus x to the 3rd minus 9x minus 54. And the only thing I think I said wrong was you should actually put them in order. So this would be first. This would be your second term because it's got the highest degree compared to this as a degree of 2. And then this has a degree of 1, and this has a degree of 0. So anyway, you should put them in order from biggest to smallest. Raise your hand if you had that one right. Okay, good. Then dividing them, the common mistake answer here is to think you can just cancel stuff you see sitting out like, oh, there's x squareds in both of them. I'll just cancel those. Why can't you just cancel those? It's not a multiply. Yeah, you got to make it into factoring. So my favorite saying again, can factor it? You should. Go ahead. The top and the bottom both factor. I'm going to give you a hint on the top, though. Factor out the negative 1 first. It's so much easier to factor this than it is to factor that. When there's a negative sticking on to the front term, factor it out and then try to factor it again. bottom part's pretty easy. If you've been doing the top 20s by now, you probably have mastered that one. And that's exactly why the top 20 has something like this on there. So that at moments like this, you don't have to try to learn so much all at one time. This part factors into x minus 3 and x plus 2. Can just keep checking it, first outside, inside, last, until you've got that factored. This negative in the front, I'm going to put right here. So now I can cancel the x minus 3's, and my final answer is negative of x plus 2 all over x plus 3. And you can distribute that negative out if you want to. Okay, so lots of intense algebra. That's what this chapter is going to be all about. And if you're good at that kind of stuff, if you're careful with your negatives, if you're good at factoring, then this unit's going to be easy. That's really what it boils down to. Is that's one of the reasons for some of you, I've had you in my class for 2 years preparing for this moment, for all this algebra, to be able to handle all that algebra. And that's what that top 20 gets you good at. Okay. This is your homework. And I'll tell you which ones you're going to do and skip. You're going to do this first page. It's got 4 parts. Here you just add the 2 functions. Here you subtract them. Don't forget to distribute the negative. Here you're going to multiply them. And that's just as simple as it seems. That times that. Just remember you got to distribute it. And then here you're going to divide them. And in this case, when you factor it, I don't think anything cancels. So don't think you always have to have stuff cancel. But I don't think in this case it will. Okay, on this problem, it's pretty straightforward except for one thing. When I'm adding these two, let's do this one together. X minus 1 plus 1 over x minus 1. Do you get they need a common denominator to be added together? All right, you've reached the big leagues. You got to be able to handle algebra. I'm going to put this over 1. Why did I do that? To give it a denominator. Now, are my denominators common? Nope. So to get a common denominator, I'm going to now multiply this side on the top and the bottom by something. When you were doing the baby kind, like 1 over 3 plus 1 over 5, you would go, okay, I need a common denominator. So I'm going to times by 5 here and here. I'm going to times by 3 here and here. That's what you were doing when you were doing the simple kind. Now my both denominators would be 15. Here, you got to multiply by what? X minus 1. Good. And here, x minus 1. If I do it on the top and the bottom, that's really just like multiplying it by 1. So now my denominators are the same. Yay, I can actually add them. All right, I know that went kind of fast, but that's x minus 1 times x minus 1 plus 1. A bunch of stuff cancels, and my answer's denominator is x minus 1. I'll let you figure it out from there, otherwise you didn't actually do anything. On the next one, it's x minus 1 minus parentheses 1 over x minus 1. And I had a really good question last hour. She said, when you're distributing and you got this one function here and you're subtracting the other function, should you distribute the negative to the top or the bottom or both? I want you to think of it this way. This is like I'm multiplying it by negative 1. What is the denominator of the negative 1? A positive 1. Now do you know, should you multiply the negative on the top or the bottom or both? On the top. If you multiplied by a negative 1 over a negative 1, isn't that really a positive 1? And you're actually adding then? True. You wouldn't want to do that. So when you multiply this thing and distribute this negative out, think of this as a negative 1 over 1, and the negative goes just on the top. All right. Now, I'm supposed to subtract these two. I can't subtract them until they have a common denominator. So what do I have to multiply this side by here? X minus 1. Do you get that now they have the same denominator? 1 times x minus 1 and x minus 1 are the same? All right. That threw in an extra twist that made that a little more hard. It's not impossible, but you will have to FOIL this thing out right there and then subtract 1. And it's all over x minus 1. All right. These will be much easier because you're just multiplying the two functions. That times that. Remember, for multiply, it's nice to have a denominator, but you do not need a common denominator to multiply. So on your multiply, you just take the tops, multiply by the bottom, and then you got x minus 1 over x minus 1, and some stuff will cancel. All right, so do not need a common denominator for those last two. Okay, then this one is good. The only thing we're really trying to get across here is when you're adding or subtracting with square roots, can you take x and actually add it to a square root of x plus 1? No, they are not like terms. So this cannot get added together. It cannot get subtracted. I mean, I can write minus, but I can't actually distribute the negative into a square root. Think about it. Can't have negatives underneath the square root. All kinds of reasons that would be bad. When you're multiplying this times this, you can't actually multiply and distribute the x in there. That's not allowed. That's like the square root symbol is like they're in jail. You can't mess with them. You can't distribute and get into the jail. You would just leave it as that times that. That's it. And same with divide. Another thing people think is when I divide by x that I can somehow cancel these x's now because there's one here and there's one there. Nope. That one's underneath the square root. It's in jail. It can't come out. Okay. And then this page. This page is all this kind of problem. Remember doing those? That's really the complicated slope formula. This one, who wants to save me a whole bunch of time and tell me what the slope of that is? Woo, that was fast. Okay. And this one, I want you to actually stick it into the formula and see what happens. See if you can figure that one out. These two, I'm going to let those go. This is the most important one on the page. That is the most typical one where you would use the difference formula on that. So you're going to stick in x plus h right here. And remember, it's got an x in two places. That also gets an x plus h. So you drop in x plus h in both of the empty spots. Then you're going to subtract f of x. Then you divide by h. And that is it, because we're going to skip the rest of them. Because I think your homework is long enough and enough challenge for you as it is. So, all right. You can skip those last two pages. And we skip these challengers. If you want to do them, feel free. Rise to the challenge. All right. I'm leaving you with enough time so you have a decent amount of time to work now. And if you want to come up and ask for help, I encourage you to do that. If you're one of the kids that, like, I'm not sure about this whole common denominator thing, I will show you one more, and you can keep watching or you can ignore me and start your homework. All right, for those of you that are wanting one more on that common denominator thing, if I needed a common denominator here, the easiest way to do it is to just say, well, I have two denominators that are different, and if I had simpler situation like that, I would multiply the two denominators. I'd say this is times 7, I'd say that's times 5. And I'd have to do the same thing here and the same thing there. Notice I end up with just the denominators multiplied. So if I was going to get a common denominator here, I would do times this by x plus 2. And I would times this to make these the same by x. And then I have a common denominator of x times x plus 2. So my denominator is x times x plus 2. And my numerator, the top part, is that. 1 times that is x plus 7. plus x. So that makes 2x plus 7. That's another common denominator type question, just in case you didn't feel awesome at that kind. And you can't factor the top here, so you can't cancel anything. Keeps it simple. All right. That's all I got for you for today.